Hi everyone. I'm going to demonstrate a tool for preparing short, auto-graded programming exercises. The idea is to give students practice writing code in a manner that's somewhat similar to completing an arithmetic worksheet. After all, writing code is more like a skill to be practiced than a set of facts to be memorized. If you aren't already familiar with this concept, here's a quick example. So this is a Jupyter workspace with a notebook that asks students to write two Python functions. Students write the requested function, test their code, then click Save and Grade to get automated feedback. And you see here the first 7 tests pass, because those are the 7 tests for the function I wrote, and the last 7 tests do not, because I didn't complete that function yet. There are a number of platforms that offer these types of exercises, including CodingBat, CloudCoder, Dodona, and Zybooks, among many others. Overall, I found this type of platform to be very effective. However, I've had two main frustrations. First, I find it somewhat difficult to create my own exercises. And second, it can be difficult to share exercises with other instructors, especially if the instructor uses a different platform. So I'm going to give a quick demo of the tool I wrote called PLNQ and explain how this tool addresses these frustrations. The key idea is that when using PLNQ, coding exercises are all defined inside of a single Jupyter notebook, inside a single IPYNB file. Authors use text blocks for the problem description, usually in a markdown format, and code blocks for the test cases and metadata. The main benefit of this approach is that many editors, including VS Code, provide separate syntax highlighting and other development tools for each type of block. In contrast, when authoring exercises for other platforms, authors must usually either manage multiple documents, one document for the problem description, one document for the test cases, one document for the metadata, and so on, or they must somehow place text, code, and metadata all into a single web form or a single document like YAML or JSON. The problem is that syntax highlighters don't tend to do a great job when you have one type of data inside of another, like a JSON file with a string that happens to be Markdown. Okay, so here's an example configuration notebook for the completed example I just demonstrated. The first block is a code block that contains some metadata for the problem set as a whole, like here is the title to that problem set. Then, for each problem, we have a text block and a code block. The text block is just the text of the problem, usually in a Markdown format. The only special thing here is the exclamation points around the function signature. And that's just so PLNQ can associate this problem description with the metadata in the code block below. The code block has two main components. The first is a reference solution for the problem. Now, a reference solution isn't strictly necessary to generate exercises, but I include it because I have a bad habit of assigning problems that are more difficult than they appear. So including this reference solution forces me to solve a problem before I assign it. And the second benefit is then I can run this reference solution to make sure that my test cases are correct. The other component in the code block is the metadata for this specific exercise. So we add that metadata with a add function method call here. And the first parameter is just the name of the function. So notice we have area of triangle here and up here inside the exclamation points in that text block above. The second parameter is a description of the function. And this is needed by the PrairieLearn setup. I'll show you where this comes in later. And then we have displayed examples. So this is a list of lists where each element here is the input parameters followed by the expected output. And these displayed examples get automatically added to the text block. Notice up here in the text block, there is just a description of the problem. But when you look at the finished product, you can see those examples have automatically been added. And of course, these are here primarily so that the students can double check that they're correctly understanding the description of the problem. So they can make sure that the example lines up with their understanding of what it is they're supposed to do. And then after the displayed examples are the test cases. These are inputs and expected outputs, but these aren't shown to the students. These are the cases run by the autograder in the background. So if you notice here for area of a triangle, there are 2 displayed examples and 5 test cases, which are precisely the 7 tests that the autograder runs. Now, there are some other bells and whistles, but I'm not going to cover those in this video. Once we have this notebook prepared, it becomes input to the PLNQ Python script, which then generates a complete PrairieLearn question. So I'll bring up the terminal here. Then I'll run PLNQ and the name of the Jupyter notebook, and then specify where I want the question to go. So I want this to go in the new PLNQ directory. And as a little shortcut, if I put a hyphen here, it'll put that exercise in a directory with the same name as the notebook. As the script runs, it not only builds the PrairieLearn question, but it also runs all the test cases through the reference solution and compares the result to the expected answer. That way, if I made any mistakes, either in the implementation of the reference solution or in setting up the test cases, PLNQ will report a problem. In other words, PLNQ helps me catch mistakes before I put a buggy assignment out in front of the students. Once the script is run successfully, we can go to the newly created directory, and we can see all the components of a PrairieLearn question. And so the info.json file is the metadata for the entire exercise set, the entire PrairieLearn question. And you can see right here the metadata from the info item here at the top of the configuration notebook, the title, topics, and tags. Everything else is standard across all of these types of exercise sets, so that's just automatically generated by the script. The second piece is the question.html. So that's the piece you see here when you first open a question. It gives a list of functions the student has to write. And again, if we go back to that original notebook file, the description is this second parameter here. Now, very quickly, if you're not familiar with PrairieLearn, PrairieLearn is a general purpose assessment platform. So across all different subjects, when students open a question, they'll do all their work on this one page. Usually you'll see the text of the question and a place to put the answer. Now, because we're working with coding specifically, and we want students to be able to write and edit and debug code, then we have that additional step of opening that Jupyter workspace. And they'll do their work on this second page here. So this is the notebook the students see. That's different from the notebook that we wrote. So you'll notice, for example, that these have automatically been filled in, and the only code blocks here are the places for the students to enter their code. You don't have that metadata, of course. Also automatically generated is the server.py file. Again, some more PrairieLearn configuration that you simply don't have to worry about when using PLNQ. Here is the workspace. There is that generated notebook file. And then finally, there is the test directory. And test.py is where that list of tests that we put in the metadata gets automatically converted into unit test tests that the autograder runs. So here you can see the inputs and the expected output. And so that's all you really need to know to get started with some basic auto-graded exercises. Like I said before, there's some additional features, so you can do things like specify the tolerance for a function that returns a floating point, or test procedures that modify a parameter rather than return a value. But I'll refer you to the documentation and some online examples for the details. So two last things to point out. First, at the moment, PLNQ only generates exercises for PrairieLearn. However, in principle, it shouldn't be very difficult to add support for CodingBat or other platforms. The input is basically the same. We just need to add a few more lines of code to generate the type of output that CodingBat or Dodona or whatever expect as input. And second, PLNQ generates a PrairieLearn question. A question is the details of a particular exercise, what is asked of the students, and that generally doesn't change much from semester to semester. To actually assign that to students, you need to go in and create what is called a PrairieLearn assessment. That refers to a question, but also adds some extra semester-specific metadata like due dates. So hopefully you can see the value in using this tool, and you can see how that it can help you get up and running very quickly with this type of auto-graded exercise. You can see the link to the GitHub there on the screen, and don't hesitate to contact me if you have any questions or like any help getting started. If you like the idea of PLNQ, but would like to add support for CodingBat or some other platform, let me know. I'd be happy to collaborate with you on that. Enjoy and let me know how it works for you.